That's really cute. Okay, so I just want you to read the questions aloud, and then we're going to talk through them, and like you can write down any like work that you want to. It would be better even to like write down some of your thoughts. You don't necessarily have to do it for the first task, but just kind of like write down what you're thinking, verbalize what you're thinking about when it comes to these problems, and we can go from there.
So like talk about it and write it down.
Yeah.
Okay.
So go ahead and read the first task out loud, and then we can talk through like what your process is.
Okay. What is a proportion? So my definition of a proportion and what I think it is a sample of a greater whole.
Can you elaborate a little bit more about that?
So I guess if you can I draw?
Mm-hmm.
Okay. So like if you have a total of something, like whether it's a population or like a total number of items or something, and you want to figure out a proportion of it, that would be like a smaller, like either percentage or like a smaller chunk of that whole.
Okay.
And yeah.
This is just for me to.
Okay.
I'm not looking for a right or wrong answer. I'm just looking for like how you think about proportions. Do you have anything else that you want to say about proportions?
No.
Okay. So then go ahead and read number 2.
Okay. How would you represent a proportional relationship? So is that asking like the relationship between the total and the number?
Mm-hmm. So I guess you kind of did this in your diagram.
Oh, okay.
But how would we, if I gave you a couple of quantities, and I'll give you some in a second, if I were to give you a relationship between 2 quantities, how would you go about representing the relationship between those 2 quantities? So if I said 2 out of 3 is proportional to 4 out of 6.
Okay.
How would you go about representing that proportional relationship?
I would probably represent them through like fractions.
Okay.
Or I guess really my go-to thing is fractions, but it just depends on what the question's asking for, whether it's like decimals, percentages, or...
Okay. So how would you... So given the quantities I just gave you, 2 out of 3 is proportional to 4 out of 6. Can you go ahead and write that down on a piece of paper? How you would like write that down? Okay,
yeah. So I would probably do 4 out of 6 is equivalent to 2 out of 3. And then I'd probably show this, how like I got to that point by dividing by 2 for each, just to show that they're equivalent.
Okay, cool. And can you discuss any more about like how you know that, like I know I told you that 2 out of 3 is proportional to 4 out of 6, but even if I just gave you those numbers, how would you prove that they were proportional? Would you go about using that kind of route?
Yeah, I would show that, I would simplify this fraction to see that, like just to show that it's equivalent, or even sometimes like it helps if I draw it out. So, so like let's say you had 4 out of 6. I'm just gonna use a circle again.
Mm-hmm.
Okay, so then I'd shade, that's not even really, but, 4 out of the 6, and then I would do the same thing with, okay, like this. And then, if my things were like even enough, it would look the same.
That's okay.
But yeah, going about it that way, but my go-to is usually with numbers and fractions. So, yes.
Perfect.
So
number 3 is kind of long.
Okay. Which of the following relationships are proportional to each other? A, 1 out of 3 and 2 out of 6. Do you want me to read the rest too? Or just like...
Sure. Go ahead.
Okay. B, 20 meters of rope weighs 1 kilogram, and 40 meters of rope weighs 2 kilograms. 2 over 5 equals 4 over 15, and person A is 75 inches and 225 pounds, and person B is 66 inches and 200. Okay. So you're just asking which ones are proportional?
Mm-hmm.
Okay. Let's see. Okay, so the first one would be proportional. 1 out of 3 is proportional to 2 out of 6. And then I did that by simplifying 2 out of 6, see if it matched up with the 1 out of 3. 20 meters of rope weighs 1 kilogram. So for this one, I don't really know like how many meters are in a kilogram, but how I would think about going about this is if 1 equals 20, and then this one is doubled to 40, and this one's also doubled, I'm going to assume that they're equivalent because it's going up by the 20 as you go up here. So I'm going to say that they're equivalent.
Mm-hmm.
C is not equivalent because there is nothing that... So, like, the only way to get to 4 is by multiplying by 2, and if you multiply 5 by 2, you don't get 15, you get 10. So, I don't think this one is equivalent. Do you want me to write if they are?
Yeah, just go ahead and circle the letter that you think is proportional.
Okay.
Yeah, that's good.
Person A is 75 inches and 225 pounds, and person B is 66 inches and 200.
You can use that if you need to. At any point during that.
Okay. Let me see.
I worked these problems out earlier, so clearing my data.
Okay. Let's see here. Sorry.
No, you're good.
I'm just making sure, like, right. Okay, yeah, these would not be proportional. Basically what I did was
Yeah, what'd you type into the calculator? And if you could just, like, write that down, like, in the margin below, that'd be good.
Okay, so I sort of went to see, like, actually, I don't know if that's right. If it's right,
what do you think about?
Can I just
like write down your thinking, or like talk me through it?
Okay, I'm not sure if it's right, but to figure out like if they would be equivalent, I put 75 over 225, and then 66 over 200, and I got 2 different numbers. But then I also did 225 divided by 75, and I got 3, and then I did 200 divided by 66, and I got 3.03 repeating. So I'm like, I don't know if that's right, but I don't think they're equivalent because they don't.
Can you go ahead and write down the like the fractional relationship you were talking about on the
Oh,
piece of paper, or just like the fractions you came up with when you were thinking about the problem. And I guess what that resulted in as well.
So that's what I got when I put those in as fractions. Okay. So yeah, I don't think that's equivalent, but I'm not sure.
Okay. So then let's just go and talk about letter B for a second. So you said that they were proportional.
Mm-hmm.
Why do you think, or I guess like, how do I word this question? You said like you needed to know meters to kilograms to be able to solve this problem, right?
Yeah, I think
Like, why
just
do
to
you
like double check that it was.
Do you think that relationship is necessarily like important, or do you think like this is just the given information and you can go like anywhere from it?
I think because like I can tell like if you have 1 kilogram, then you have 20 meters, and then it gives you if you have 2, then you have 40. So then I think it like is starting a pattern, and I can tell. But if it was just like maybe like 1 kilogram is 20 and then 2 is like 35, then I think maybe it would be easier to see if you knew how many meters are in a kilogram. But I think because it's showing a slight pattern, like I would assume that 3 kilograms is 60 meters kind of thing, because it's just doubling. So I think for this problem, it's not necessary to know how many meters are in a kilogram. And like with this kind of problem, you can just take it and work with it.
Right, because like what quantities are related here?
Like both are like you mean both are meters and both are kilograms.
So like how does the meters relate to kilograms?
Wait, I don't know what you mean.
Maybe I didn't word this correctly. Because we're given that 20 meters of rope weighs 1 kilogram. So the meters and the kilograms relate to each other quantitatively, is what I'm trying to get at.
Okay.
And that's how you can like think about looking at this problem as well.
Okay.
But you, I think you got it.
Okay.
Yeah.
Okay.
Hello.
How's it going?
Good. We're just doing an interview
A mock interview?
for my class. So,
Oh, sorry to interrupt.
you're good.
Ugh, disgusting. Candy corn everywhere. Animals.
Perfect. Okay. We'll go ahead and move on to the next task.
Okay. Paul can walk 75 steps in 5 minutes. How long will it take Paul to walk 275 steps? Okay. I think I know how this is. Okay. So about 18 minutes. is my estimated answer because I got a decimal.
Okay, cool. So talk me how you set this problem up and how you found it, your answer.
Okay, so we're trying to figure out how many minutes it'll take for him to do 275 steps. So we already know that it took 5 minutes for him to walk 75. So I put 5 over the 75, and then I used X to represent the amount of time that we wanted to find over the 275 steps we knew he took, and then I cross-multiplied the 5 with the 275 and the 75 with X, and then I got 75X equals 1,375, and then I just solved for X, and I got about 18 minutes to walk 275 steps.
How did you know to say 5 over 75?
So I just kind of wanted to put like how many, like what we knew over, like, wait. I wanted to put the time over the amount of steps because we were looking for the time, and I like remember learning like how to do this kind of stuff, and you always want what you're looking for on the top of the proportion or fraction.
Okay.
So I just since we're looking for a time and we had 5, that's why I decided to put it on top.
Okay. So how do these quantities relate to each other?
So how do the 5 minutes and 75 steps, and then the 18 minutes and 275 steps?
Right.
Okay. I think they relate to each other. Like, do you mean if they're like equivalent, kind of like
Like how many steps does it like, or how am I trying to word this? Just like how steps and minutes relate to each other. So like, could you even find like what the rate was, like how many steps I take in a minute, like how those relate to each other?
So I mean, you could find how many steps I think that he would take in a minute if you divided the 75 by 5, just to figure out how many he would take in a minute.
Mm-hmm.
And I guess you could maybe multiply, well, I don't know, actually, never mind. But I think that's how you would find it in 1 minute, and from there you could figure out how many, with the 275 steps, how many, like, he would take in set amount of minutes, kind of. So I think they relate to each other because you, like, take a certain amount of steps in, I don't know, never mind. In a certain amount of...
In 1 minute?
Yeah.
Yeah, okay, yeah. That's all I was just trying to get to, so. Okay, cool. And just walk me through one more time how you solved for X.
Okay, so I put the minutes we already knew over the steps that we knew correlated to the 5 minutes, so 5 over 75, and then I put X as the time that we were trying to figure out over the 275 steps, and then cross-multiplied 5 by 275 and 75 by X, and then you get 75X equals 1,375, and then just to solve for X, I just did like order of operations, so you divide by 75, divide by 75, and then so that one cancels out, and you just have X equals, and then 18 minutes. It was like 18.3 repeating, So I just rounded it to about 18 minutes.
Perfect. And then I see that you have these two fractions here, how you set them up, and you cross multiplied from here, but like, are these equivalent fractions or proportions, or are these just like two that you just kind of wrote and just kind of went from there? Does my question make sense?
Yeah, are you saying are they like proportional to each other?
Mm-hmm.
Yeah, I think they are because you're basing like how many steps Paul takes and how many said minutes. So it would be like different if it was comparing two different people walking and how many minutes they take. But since it's him and he's probably walking at the same pace, then I would think this is equivalent because it's just like sort of a progression over time and then like adding on to steps of that. So I think they are proportional to each other.
And then you would put like an equal sign there.
Yeah, sorry.
Yeah, that's what I was.
Sorry.
Trying to inquire about. Like, okay, perfect. All right, let's go on to the next one.
Okay. A new test shows that a car can travel 335 miles on 10 gallons of gas. How far can you travel on 70 gallons?
We were just in your room.
Or 75 gallons of gas.
Sorry, I have a lot of homework, so I'm like not trying to think.
No, focus on that, seriously.
Did you guys use him?
Yeah, can you tell?
I did not over here.
I
I'll see you later though.
Okay, bye.
Okay, I won't ask you to read it again, but so you just start them. All right, go for it.
Okay. Shows a car can travel 10 gallons. Sorry, I'm just like thinking about how to start it. Okay. I don't know if this is right. I think it's the same like setup as this, but you're just doing it like with two. But I think what's throwing me off is like the 335 being bigger than the 10 kind of deal, and that just looking weird as writing it as a. So I'm just gonna go for it, and I'll see if it's wrong.
Cool. So walk me through what you did first problem.
Okay, so to figure out how many miles on 70 gallons of gas, I put the miles that we already knew over the 10 gallons of gas that was given in the problem. And then I said that would be equivalent to the number of miles we're trying to find over the 70 gallons of gas. So again, I cross-multiplied the 335 by the 70 and then the x for the 10 and got 10x equals 23,450, and then I divided that by 10 and got 2,345 miles. And then I did the same thing with B, but just with 75 gallons instead of the 70, and I got 2,512.5 miles. So I think what was just throwing me off in the beginning is just my brain being like, it's so weird you have a bigger number over a smaller number. I don't think that's right, kind of deal. So I was like second guessing myself.
How come you thought that was not right?
I don't know. I think just because I'm like so used to having like the smaller number on top than on the bottom, but like then I realized that we're talking about like proportion kind of things rather than fractions. So it like messed me up a bit, but I think this is right. So
Okay. And then you mentioned earlier about how you always put your unknown value or what you're always looking for at the top of your fraction per se.
Yeah.
And I see you've done that through all three of these problems. And so elaborate a little bit more about why you put the unknown value in the top. Like I know that's how you were taught, but
yeah. Okay. Can I just like write it out and see like the other way? Okay.
Like would it work the other way if you were to put it in the bottom? And why?
I'm not really sure, so let me just
Try it. Try it out.
quick. So I guess it would work the other way around because you're still multiplying the 10 by the x, even if it was flip-flopped in and you're multiplying the 335 by the 70. So I guess you could. I just was taught that it always goes on top, and so I don't know. I guess it really doesn't matter.
Why do you think it doesn't like matter? Like how do I want to word this?
I think I know what you mean. Like
how come it works both ways?
Yeah, I think it works both ways as long as you have what you're looking for next to what was already given for what you're looking for. So like we're looking for miles, so it should be next to like the miles already given in the problem. So like as long as the setup is same for each individual proportion, so whether that's 10 miles or 10 gallons over the 330 miles or vice versa, like as long as the gallons line up and the miles line up, then it works.
Right.
Okay.
So to kind of rephrase what you're saying, if we have similar quantities of similar units, right, then it would work that way. Is that what you're saying?
Yeah.
Because we had 10 gallons in relation to 70 gallons and miles to our unknown miles. That's what you're saying? Okay, cool. And so would it work if those were reversed? If you had 10 over 35 equals x over 70, would that still work? Why or why not?
10 over 35 and x over 70?
Right. So if we just to try it out, like if we were to switch those two values, would it still work? Would that relationship still be proportional?
I don't think it would still work because the like quantities and proportions wouldn't be the same because so if you had 10 over the 335, so this is gallons, whereas this is miles, and then flipped it so you had miles up here and then the 70 gallons here, you would be multiplying the like you'd be multiplying the gallons and the miles together rather trying to figure out how many like gallons were in said mile. Like I don't think because you wouldn't get the same response. So I think the order that you have, like what's on top and what's on bottom matters in the separate like quantity kind of things rather than the problem.
Right. And those quantities relate to each other because
they relate to each other because
or how do they relate to each other? Like because miles is related to gallons, right?
yeah, because like how far you go depends on how many gallons of gas that you're using. So we're trying to figure out like, okay, if I have this amount of gas, how far can I go? Kind of deal.
Yeah. Very cool. Well, I think that is good enough.
Okay,
So thank you.
thank you.
Thank you very much.